Hi everyone, welcome back. So today we're going to talk about some problems in 12.1. So in order to let you be familiarized with this chapter and this topic, I'll include some problems in this section, these lessons. Okay, right. So first of all, it's a revision of formulas that you have learned in the previous class. First one is the n-term formula. So you have to find the fifth term, sixth term, then you substitute n equals 6, and with the a, remember, it's first term. Then d is a common difference. And Sn, this one means the sum of the first n term. So let's say I want to sum for the first 10 terms, so I'll be finding S10. Okay? Then this one, last one, means that if you want to know the sum from maybe 5th term to the 10th term, then what you can do is to take the sum of the first 10 term minus the sum of the first 4 terms, because you want 5th term to 10th term. So you have to minus the sum of the first 4 terms. Okay? So I think we can get it started. All right. So now you are given that 4x plus 5, 31 minus 5x is an AP. So find x, find the common difference, and find the sum from 11th to 20th term. Okay, now A. Before going into details here, what you can see is that this one to this one, this one to this one, it must be the same. Okay, because it tells you that it's an AP already. So if it tells you that it's an AP already, so you know this difference and this difference, they will be the same. Okay, so hence we can do something. So the d will be equals to 4x plus 5 minus 5, this one minus this one. This is term 2 minus term 1. This is term 3 minus term 2. They are the same. Okay, so from here we can get some relationship between them, right? Okay, we get something like this one. Hence we can solve for this one and we will know x immediately. Okay, so we move the things over, x will be equals to 2. Okay, x will be equal to 2. Right, no problem. Okay, second, find the common difference. That's even simpler, because just now what you did was d is equal to this one or d is equal to this one. Now what you can do, substitute this x into here and get the answer. Okay, so d, let's say we just take this one, substitute, then we get 4x, which is 4 times 2, which is 8. So d is 8. Okay, last one. Find the sum from 11th term to 20th term. So this one is just substitute into the formula. So C, A is this, D is this. So that's the thing that you have found already just now. D and okay, yeah, right? So Sn is given by this formula. Okay, and remember this is 2, this is not A only. It's not A plus m minus 1 times D is 2A, because this is sum of n. Okay, sum of first n term. Right? Then substitute things inside. Right, then you are going to have something like this one, right? So it's 11th term to 20th term. Okay? In 11th term to 20th term, like the one that I said just now. So it's a sum of the first 20 terms, then minus the sum of the first 10 terms. Because this one, 11th term to 20th term, means that 11 is inside, right? Okay, 11 is inside. So you minus off the sum of the first 10 terms. So it's S20 minus S10. Okay, so you substitute into here, for 20 and 10, you get the answer. Okay, which is this. Okay, right? Yes, that's quite easy, right? Okay, let's move on. So now there's a new formula here, but then sometimes you use it, sometimes you won't. But I'll just put it here so that in case you need it, okay? So let's say an arithmetic progression, it's having a finite number of terms, means that like some number, comma, some number, comma, some number, then eventually it will end with some number here. It doesn't go like dot, 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 okay? With the dot, 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 it means that it has infinitely many terms, okay? So here, if it stops with a number, means that it's a finite term, okay? If it has finite terms, then n, the n term is the last term. So meaning that the n is the last term. First term is term 1, then last term will be term n. Then the sum of all the terms will be this one, right? Given by this formula, correct? Okay, this formula is from the things that we have learned last lesson. So this formula you probably already remember. Okay, okay. So now I can actually separate this 2a plus n minus 1 times d into a plus n minus 1 times d. Correct? So this is something that you know what it is, right? Okay. So what is this? This is n term. Okay. This is Tn. Correct? Okay, the formula for Tn is given by this one, right? Okay, right. So now, think about this. Look at what we have described here. We take the n term to be the last term. So meaning that this one is the n term, Tn. Okay, which means that this is the last term, the value of the last term. Okay, so we will call this one a plus l. So now you got a new formula, right? So if you want to find the sum of all the terms, okay, for a finite arithmetic progression, what you can do, if you know the first term, the value of first term, and the value of the last term, then you just take n divided by 2, first term value plus the last term value. Okay, that's what we have here. Okay, no problem, right? Okay, so sum of all terms in finite AP is equal to Sn equal to 102 a plus l. So this is happening when you know the last term value. Okay, then that's very simple. This is like a simplified version of this one, but this one definitely you will need to use it. So you can remember this one and this one both. Okay, so if you know how to derive it like the one that I explained to you, then you don't have to remember this one, right? Okay, you can derive it yourself. Right. Okay, so now we have a new problem here. So 3, 7, 11, 99. So total number of terms, sum of all the terms in the AP. So now you know this is an AP already. Okay. So first of all, A. You see, A, you want the total number of terms. What do? So there's a hidden information here. You want to try to find the last term, right? What is the index? So this is Tn. So Tn is 99. So Tn is 99 means that 99 is equal to the a plus n minus 1 times d. Okay, so you have this one minus over, then divided by 4. Then you have this n minus 1, add it over. Then you have 25. Okay, so you have found the total number of terms. Okay, it's not stated here, right? Okay, you see here it stops at 99, means that that's the last term. If it's last term, then you know you can name Tn, where n is the last term, right? Okay, n is the last term. Okay, so then you have this. N is equal to 5. Okay, sum of all the terms in the AP. So you want to find sum of all the terms in AP, there are a few ways, right? Like the one that you just learned. So can you try to use the formula that we just learned to solve this? Yes, very simple. So now, it's just S25. Because you know this is, this is wrong, sorry. This one should be n equal to 25. There's a typo here. Okay, so this S25, 25th term is the last term. This is T25. This is T1. This is T25. Okay, so you call this T1 equals to A, right? And you call this T25 because it's the last term, so you call it L. Okay, so S25 will be n divided by 2. Remember the formula? N divided by 2, then A plus L. Okay, A plus L. So Sn is equal to n over 2, first term plus the last term. Okay, which is very simple. So you got this one, then you can get the answer immediately. Okay, 1275. Okay, so you got this. Right, no problem. Great, so now you know there's an application of this one, right? Okay, so another way of doing this one is to do what? You just substitute it into Sn equals to n divided by 2, then 2a plus n minus 1 times d. So this one you get the exact same answer. But then this one is slightly harder, right? Because here is longer, right? It's longer. This is very simple. I just take two numbers, add them up, then divide by 2 multiplied by n, I get the answer. Okay, so that's the difference. Okay, all right, no problem. So let's see next one. In an AP, the fourth term is 14, and the sum of the first 5 terms is 55. How do you decode this one? Fourth term is 14, so T4 is 14. Okay, and what is this? Sum of first 5 terms is 55. S5 is 55. Okay, so that one we will leave it here. Okay, so this by definition T4 equal 14. So left hand side T4, you can apply the formula, right? Use the formula. T4 is equals to A plus 4 minus 1 times D. Okay, then you write that out. Okay, I simplify a bit into here. Then I let A to stay on one side. So A is equal to 14 minus 3D. Next, here, this one relates to this one. This one, sum of the first 5 terms is 55. So S5 is 55. Again, we substitute the formula to the left hand side. Then it will give us this thing. Okay? We don't use something like A plus LO here because we do not know whether the AP is a finite one or infinite one. And that one will cause you a little bit of problem also. Why? Because here you have A and D, but you cannot solve it. Here you should expect another A and D so that you can solve the simultaneous equations. Okay? So here you simplify it. Eventually you get something like this. Oh, it's nice here and it's nice here. So now what you can do? You can name this one to be first equation, name this one to be second equation, then you substitute first one into the second one. Okay? You substitute 1 into 2. Then you get something like that, 14 minus 3D minus plus 2D is equal to 11. Solve for D. D will give you 3. How do you get 3? This one you move it to this side, you get D on this side. That one you move it over, you get 3. Okay? So if D is equal to 3, you substitute back into here, you get an answer. Okay? A is 14 minus 3 times 3, which is 5. So now your conclusion is A is 5 and D is 3. So you want to find the first term and the common difference, you have done it in one whole thing here. Okay? You can't actually solve it one by one. Okay? So this is like you have to do it like in one go. Okay? This whole thing. Okay? No problem? If you have any problem, you can always pause the video or rewind it. Okay? Next. Okay, problem number 4. 22, 26, 30 form an arithmetic progression. So find the smallest value of n such that the nth term is bigger than 100. Okay, so I want to warn you first. So this type of question is very possible in your SPM. Sometimes it will be like, I think most likely it will be in the first paper 1. Okay, so now here, what does it mean? It means that you want to find n such that Tn is bigger than 100, and this n has to be the smallest one. So meaning that, let's say Tn is 100, I tell you one value, like T of 5 is 101, T of 6 is 105, and T of 7 is 109. What is the smallest n such that Tn is bigger than 100? So that's 5, right? Okay? That's 5, right? That's the smallest one. So that's what it means here. Okay? Right. So we want to find the smallest value such that this one is bigger than 100. So this is the main point here. This is the main point, meaning that you are just going to use this thing. Okay? Right there. Okay, first of all, it's like always, whenever you see an arithmetic progression or geometric progression, later on you'll learn it. First thing you have to write is the information that has to be there. A and D. A is 22. D you can see is 4. Okay? D is 4. So what you can do? You can write this out. Write down this inequality. Tn is bigger than 100. Left hand side Tn, there's formula, right? There's formula. So it's A plus n minus 1 times D is bigger than 100. So the A and D are known values. Put it in. Okay? Put it in. So we simplify this thing first. Then you get 4n minus 4 is bigger than 78. Hence, 4n is bigger than 82 and is bigger than 20.5. So now, you know that in order for Tn to be bigger than 100, n has to be bigger than 20.5. So, what is your answer? Your answer should be 21, right? Okay? It's not to say it's rounding up because it's 0.5. Even if it's 20.0001, it's still 21. Okay? Why? Because you want an integer that is bigger than this one, that is bigger than this one. Okay? An integer. So a whole number there. So since n must be an integer and must be greater than 20.5, so your choice must be 21. Cannot be 22, cannot be 23, because it is the smallest. Okay, right? Okay, do some revision on this. Okay, next. So this is hot question. So hot. All right. So now this is something that you might be afraid of, but don't worry about this one. You don't. It's not very difficult for this one. Later on, I'll give you slightly more difficult questions. So this is still very simple. So now you have in a lecture hall, you have 15 rows. The first row starts with 20 seats. Second row has 22 seats, and third row it has 24 seats, and so on in this pattern. Okay, so write down the first term and the common difference. Okay, pause the video and try this. Okay, I think you can do it, right? This is very simple. Okay. All right, let's solve this. Okay, first row is 20, second row is 22, third row is 24, and you know dot dot dot. Okay. So now, the last row, because it only has 15 rows, right? So you stop at 15, okay? So it's a finite AP, yeah? It's a finite AP. So this is the last row. This one will form a arithmetic progression. You'll form an arithmetic progression with A is equal to 20, and what's the D? D is 2. Okay, that's very simple. Okay, so we are done for question 1, right? Because first term and the common difference. So we are done already. Okay? In case you don't know, because it's very simple. Okay? Right, next. How many seats are there in the hall? Okay, now let me ask you. How many rows are there in this hall? 15, right? So 15 is the last row. So what you are going to do here in terms of the notation, what you are going to find? You're going to find the sum of the first 15 terms. Okay, means S15, right? Okay, like let's say the first row has 20, second row has 22. You want the sum of the first 15 rows, right? So you're gonna find S15. Okay, to find the sum of all 15 rows of the seats, so you're gonna find S15. So that's the formula. Okay, that's the formula you have. I think first question we didn't find the last row how many values, right? If we know this one is some values, we would be taking the first row plus the last row, then n divided by 2. Okay, and that will be easy. Okay, but no, it's fine. We are just going to use the normal formula as n divided by 2 to a n minus 1 times d. Okay, substitute everything in because a and d is there already. So I'll just show you the steps. Put it in, then you get something like this: 68 over 2 times 15. You get 510. So that's there are 510 seats that can accommodate for students in the lecture hall. All right, great. This one should be the last one. Okay, Ashraf was hired by a local restaurant at a starting salary of 3,000 a month. If the company gives him an 250 ringgit increase in his annual salary, means that after 1 year, originally it was 3,000 this year, then next year starting in January, it will be 3,200, 500. I mean 3,250, sorry. Okay, so what would he be getting at the start of his 10th year in the company? So after 10 years, what will happen? Okay, the second is like if he regularly saves 10% of his monthly salary, what will be his total savings at the beginning of the 10th year? Okay, let's see. Pause the video. Okay, try this. Okay, let's do it. So now the scenario, if you don't understand, you should just plot the things out, right? Okay, first year is 3,000. How about second year? 3,250, then 3,500, and so on. Then the last one, I don't know. Just gonna write it out. Okay, the 10th year. All right. So now the T10 is the thing that you are gonna find. You understand that? Okay, because you want to know the how much would he be getting at the start of the 10th year. Okay, so now at the start of this year, first year, then it will be this one. Then at the start of the 10th year is T10. Okay, so this one will form an AP. Do you see that? This one forms an AP. Okay, so 3,000, 3,250 to 3,500 and so on. So you can tell the A is 3,000, the D is 250. Okay, so now you want to find T10. Very simple, substituting the formula. So these so-called HOTS questions is that if you can formulate the question properly in terms of like converting these words into things like this one, then it's very simple. So let's say now I give you A, I give you D, then I'll ask you, I want to find T10. Is it difficult? No, exactly. That's like very simple, right? The easiest task that you can have. So T10 is equal to this thing, okay? A plus n minus 1 times D, okay? And then it's just going to be 5250. So 5250 is in monetary value, so that's RM 5250. Okay, no problem? Good. So this is fine. So next one. Now, you have to think about this one very carefully. So this one is the start of the 10th year. So the 10th year is not included, right? Okay, the 10th year, the saving is not included. So you have first year, second year, until the 9th year of savings. The 10th year is not included in here. Okay, you understand that? Okay, because this one is at the start of the 10th year, what will be the savings? Okay, so it's up to the December of last year, right? Okay, that's why. So it's up to the December of the 9th year. Okay, so you got to be careful about this one. It's not S10. Okay, so now, do you agree that the total saving? Okay, let me ask you this. I save 10% a month, every month. Okay, then it's equivalent that I save 10% for the annual salary, 10%, correct? So now, let's say I save every month and 10%, and I save every year 10%. It's the same, right? Okay, one you just have to multiply by 12, right? Okay, so now, do you agree that the total savings here will be 12 months times S9? S9 means what? S9 means like, oh, this year I get 3,000, next year I get 3,250, then this I get 3,500. So I add this up until the 9th year. But that one is only 1 month, right? Okay, you gotta multiply by 12. That means that this is the salary that you make from the 9 years. 9 years. Okay, 9 years you make this much. Okay, 9 years you make this much, but then you only save 10%. Means that you multiply by 10%, which is 0.1. Okay, that's why you have this formula over here. Okay, I guess you are fine, right? Okay, you are fine so far? Okay, so because we need to calculate this one, the only things that we do not know, which is S9. S9 is 902 2A plus n minus 1 times D. Okay, so you got this one. Okay, so just refer to that one. So we will have some value like this, 36000. So we substitute this thing into this, and we will have total saving is 12 times 3,600 times 0.1, which gives us 43200. Okay, right. So this one is a bit tricky, right? It's a bit tricky. Yeah, you can do this one if you understand this problem here. Okay, so the total savings at the beginning of the 10th year is RM 43200. Okay, no problem. Good. So what you can do is like try to don't look at my answer and do it yourself and see whether you can figure this out. Okay. All right. So I'll see you next time. Bye bye.